Okay, good afternoon, ladies and gentlemen. Here to just say about the sort of new development that we've got on the market on the Terra anchor. My name's Lloyd Ingles. I'm the engineering manager at FMS for mooring products. Next. There. Okay, so I think a lot in the room already familiar with FMS, so I'm just explaining about this slide, just a little bit about the sort of capabilities of First Marine products. So basically, obviously, what I'm presenting about is the anchor design, but we're also looking at sort of mooring products, mooring equipment. I mean, part of it, and geotechnical engineering. So, you know, supplementing the sort of installation, mooring design capabilities of FMS. We're looking at bespoke mooring equipment, and also supporting the technical specification for other components in the mooring systems, because cost only tells you so much. You need to sort of look at the whole sort of life cycle and optimize the technical capabilities of mooring components to get the best value for the equipment and long-term service. Now, as part of joining, since 2 years, sort of last year we launched the Terra anchor. It may look quite similar for those of you not so involved in drag anchor design, but overall I got the best optimization. So the anchor looks small bits that look kind of inconsequential, actually make a big difference in performance. You know, you take off a little bit of the shank or the fluke and it can cause quite vast differences. So there was quite a lot that went into that, even though just drag anchors from the outside look all relatively similar. So what we have here is like the best optimized performing anchor for general soils. And when it comes to hard soils, we've got a novel pick point design. So the best way to describe this is that if you think about a excavator bucket, so conventional drag anchors, what's currently used in the industry, you've got the pick point on the vertical plate, and then you've got resistance that goes up onto the fluke, so the soil going into the fluke. So if you think of your excavator bucket, it's like the pick point being underneath. You've got a single pick point, it drags, you're still getting resistance before you get that soil into the excavator bucket. First part of the design change, put the pick point right on the fluke plate. It's doing the effort of getting the soil straight into the fluke where you want to minimize the resistance. Second part of the design feature is that it came from technical mining theory. So when I was reading a lot of mining theory, basically how mining tools work is that you don't have like a single pick point. What you have is a single pick point, which we actually see with drag anchors with practical knowledge of that it just drags and you actually just get a little trench or scratch on the surface. When you look at mining tools, they've got multiple pick points. And the reason for that is that if they're optimal distance apart, the pick points will crumble the soil. So essentially they'll crack the soil. So the 3 pick points that I've got is just optimized for the sort of fluke shape. So that we're sort of trenching in a sort of shovel bit at the front. And that is to work to enable that in really hard soil conditions, it's new technology that means that we'll crumble the soil and get a better capacity when compared to existing drag anchors in the market. Now obviously the proof's in the pudding, so what I'm here to talk about is the offshore testing and the commercial contract that came off the back of that. So the offshore test, it was actually, for those of you who are familiar, it's actually quite a hard condition in the North Sea, up to 250 kilopascals, which is a site that's known with existing anchors have struggled in. And we were using a 15-ton size of our anchor. We located sensors in anchor and did the test out, which I'll show in the next slide. So we got the Odin Viking for the test. And what's critical with testing is to make sure you've got multiple measurement points. So we've got IMU for, well, only a couple of IMUs in the anchor, so redundancy there, so that we can measure the orientation, which I'll show some graphs later on. We've also got drag distance measured by multiple points, both the trims and buoy, measured up links, make sure you've got redundancy in case one measurement doesn't quite match up, and obviously the vessel sort of measurement. Now, as you'll all be familiar, winches on vessels are not always super reliable. They haven't been calibrated. Most of the time they get installed during the shipyard phase, they get calibrated, and then they never properly get calibrated to the load. So we used inline tensioner, running tensioner monitor. So this was a calibrated system. Obviously not as good as a direct line tensioner system, but it did mean that we have both the vessel winch and this inline tensioner system that had calibration to sort of monitor 2 measurements. And we initiated the anchor, so the left-hand image will just show as it starts to go in, just before it goes in, so as it's laid on the seabed, how the orientation is. And the right-hand image shows it post-installation. As I mentioned again, this is a very hard clay soil site, and basically what we see as this image goes round is just, as opposed to remodeling, as you conventionally get, first of all, we see the shank that's on the surface. It didn't bend much, it was only the fluke for 230-ton load. But as it goes back, we kind of see that the soil flaked, and this is what you'll see in really hard soil conditions. It's very challenging soil conditioning for a good sort of benchmark for the first test of the anchor. We'll just let it go around. So that's it, as you see this, and it's actually exposed the fluke at the back, so it's sort of evidence of the challenging soil conditions. So with the monitoring, we actually got some really good data. As the orange line is the pitch. So what was really nice is it actually correlated to my test tank and scale testing. And the tension line is the blue line. As we can see, it's got, so from the correlation of the measurements, the ROV footage, and the IMUs located, we've got good accurate measurements on its orientation and depth. So essentially, it went in 1 meter below the mud line. And the other thing that's I find really interesting is just the scouring that you see in the anchor and why this anchor performs really well in hard soil conditions. You may have seen several photos in the past of having experience in challenging hard soil conditions, and you get the scouring along the paintwork. The important thing about this one is that we get it on the fluke, which is what you want, but the shank design means that the scouring of the paintwork, even though it was almost full embedded, was limited to the very tip of the shank. Essentially, when it comes to drag anchor design, an ideal scenario was that you just got the fluke plate and it embeds in, and because the shank creates resistance. That's obviously not possible because you need a shank. It would be impossible to handle an anchor and get it in properly without one. But the design of the shank means that we minimize the resistance when it goes in hard soils. Furthermore, it was also a combination on the handling of the anchor, because obviously if you can't get it to the seabed, or the struggle to get to the seabed, it can perform as well as you like on the seabed and geotechnically, but if it's been a hassle getting there, or there's issues getting it there, then you'll tarnish your reputation. So a little bit more about that later on in these slides. Test 2, we didn't manage, due to weather limitations, take up quite the same tension, but we did manage to get the same sort of data set from it, meaning I've got 2 good tests where we got really good correlation, and it correlated well with our scale testing as well. So this is leads on, slightly lower just for the lower tension, but is as expected sort of scenario. And just from the ROV footage, shank clearly on the seabed post-installation, even the head shackle's there, but the fluke's well embedded, exactly what you want to minimize resistance. So following a successful test, we actually got our first commercial project. The test took place in October, and then by the time the sort of client decided to proceed with it, we got 7 weeks to get them ready in the quayside, which was during the Christmas break, and believe me, it's tough dealing with multiple suppliers to get everything together when different countries and different regions are all on holiday at a different time. They were actually successfully on the quayside on time. We got them, with a 7-week window, we got them there ready in Montrose to be mobilized. And when this was happening, it was February, so end of February, there was a few storms, which lots of you probably remember. So it obviously meant really narrow weather windows, which meant it was extra critical that these go in, otherwise we're responsible for holding up the rig. Thankfully, as expected, it all went successfully. Every anchor installed first time on a site that's been known to be challenging by previous history. And it went to a very short drag distance. First time was short drag, it's comparative to even other anchors that are on the market. Now, the important thing as well that we had to learn, so geotechnically, obviously this is a good performing anchor, we're happy with the results. But we also made sure that we try and make something that's easy to handle. It's important that the guys on the deck can handle it. You get your reputation's built by satisfying the deck crew and people who handle this in the quayside as much as you'll get the people who, as much as it goes in. So we've got a few design features which are either equivalent to what's on the market or supersede it. First point that's a nifty design feature is we're actually the first anchor that could be certified as a 3-point lift in either DMV or roller. So you may well know that, drag anchor handling is a sort of grey area with regards to responsibility of lifting. It obviously costs more for the certification, so we haven't done it for this anchors, but we can actually get this anchor with the way that we've got the lift points arranged as a certified lift for offshore. The rear lift points are also at a good angle, so the top left-hand image is just how we connect for changing the fluke angle. The good solid points that only sort of are just about chest height, which means the guys working either on the quayside or onshore or on the back deck can get good access to it, hook it in. Nice and easy means it's limiting sort of the handling issues with that. It's still a bit stable on deck. Obviously, I did as much as I could in the design phase. It's actually one of the aspects quite difficult to juggle in an anchor design because you've got the geotechnical performance, which wants one set of characteristics to optimize that, but then you've also got the aspect of back deck, and you're trying to make it safe and really work. So you want to make it nice and safe in the back deck, which it was feedback in the crew, we got that. Efficient pinholes, so basically you can see in the top photo here, there's nice clearance in the pinholes just for changing pins on set, and a good level of safe height of operation. Now obviously we got all this sort of as a preempted, but we also got good feedback. So we've had to take from the first job, so from the prototype test and the first job, there wasn't time to do anything, it was a rush project, but there was a few things that we got notification of, and we are now amending for the new design. So little design revisions that we'll tweak. I mean, the first one is the angle of the fluke. On paper, you don't really think about it. It's slightly at an angle to try and land on the anchor. So I'm redesigning it so that we can just lift it with a forklift directly on the shank. Another one is just a little notch at the very front that caused a little step in the stern roller. With handling procedures, we'll be able to mitigate it. This one for these use, which were in our own use, but for ones that we bring to market, we're going to ensure that that's eliminated. So basically a little step, it didn't cause it much harm. Some people liked it because it reduced the mud, but we obviously see that, if you've got some sensitive operations, high sea states, it could be an issue, so we're eliminating that from future designs. So this is a sort of a process that we want to make, and we want to make sure that we always get feedback and take that on board to ensure that it's a good handling product for the seabed, but also it's good to handle. So the conclusion is that, we've got really good performance with the offshore tests. It aligned with my sort of prototype and calculations during the design process. First project we completed successfully, which was a location that has had struggling with some of anchors in the past. Handling T-sides was mostly successful, but the most important thing is that we did take feedback, and we're looking at keeping that ongoing. You get invaluable experience. We've got guys that do it every day that give good experience, but also went on board and spoke to the vessel crews and got their feedback as well. So we're always making sure we take this as part of the design loop, and going forward, we think that we should be able to make something that meets as best fit all requirements. I hope you enjoyed the presentation, and I look forward to if you have any questions.
Okay, thank you very much, Lloyd. That was great. We'll go to the audience first for questions. A shy bunch today. Come on, someone. There we go. Make it a hard one.
It is hard. Lloyd, as we scale up from 12, 15 ton anchors to 35 and whatever we have to get to for floating wind, you mentioned deck safety. When we scale up, is that a direct linear scale? The anchor gets bigger and those handling points get more complex or less, or is it just the same?
I'd have to look. I mean, there'd be a certain point where it's just going to be even with something that you've tried to manage, which would go fine to 20, 25 ton, would start to just be big, full stop. But that's where I'd look, if you're looking at that sort of orders and sort of volume, say, for addressing floating winds, then you'd look at, doing something bespoke for that sort of size because it's worth your while. If it's this sort of anchor, you've got a cost efficiencies to consider, so you need something that's set, designed, cost effective to bring out. floating wind's bespoke for one-off, or permanent moorings, it kind of changes a little bit of the requirements. So yeah, we'd look at overcoming that when that becomes a potential challenge.
Because what we heard earlier, we'll be using the same vessel, won't we? We'll be using that same 12-ton, 15-ton anchor handling vessel to handle, not just in the water, but again on the back deck, a much bigger anchor.
Yeah, I mean, that's obviously, there's no way around some of the handling, it's, if the anchor's that size for the loads, I mean, it's then getting onto those with the cross-tensioning and how you do that as well. So, yeah, you're going to require a lot more engineering and thought for these larger scales anchors than you would do for what, essentially modu operations, which is a regular, sort of operation and looks at efficiencies in those sense.
Question at the back from Sam.
Thank you. That was a fantastic presentation. You said at the beginning that the new three-point design that you had improved the efficiency. Is there any kind of percentage terms of how much more efficient this design is compared to?
It's sol dependent. I mean, obviously the harder the sol, the better it is, so it's not something that I can rattle off figures on, but something that, if you've got a specific site sol condition, I can go and investigate it and sort of estimate or get, sort of calculate the performance boost in that particular sol condition.
Yeah, I think obviously if that data came out, you could present that towards the anchor handling vessels, especially with the increased cost. If they knew that they could install these anchors probably first time compared to another one that would take a few more tries and has more vessel time, there could be a massive cost saving in that.
Yeah, I mean, it's targeted, it's complicated in saying exact figures, but yeah.
Especially with competitors in the room.
Thank you.
Good, thanks, Sam. I maybe missed it in the presentation, but the fluke settings, have you gone for the traditional?
Yeah, I mean, to be honest, I went through a stage of, I optimized or came up with some innovations where I thought would be a gain, but in the overall sense is that, you don't want to change too much, because if you come up with something radically different, let's say for the sake of it, you have crews that suddenly aren't used to it, the handling suddenly changed. So yeah, it's regular fluke setting changes, and a lot of the handling characteristics is to keep synergies with, if I go to my bosses and said that we need to write a whole new set of procedures at FMS for deploying these anchors, I'd be the first one to hear about it. So. Yeah,
very good. And from the prototype to the commercial scale, if you like, how much did it differ?
So those ones are ready, but there's just small tweaks that were done just to aid in improvement and efficiency. So you won't notice much difference. It's just small things I've done that have. Yeah, I mean, it's ready. I've got the drawing set ready for inquiries on the go. So
excellent.
It is commercial now.
Okay. Any more questions? All good? Okay. Thank you, Lloyd.
Okay. Thank you.
Brilliant.